So choose this again. Okay. Quickly for the number of moles. Don't forget mole. Okay. Let me just turn off the camera. Okay, switch it to the other position. 1 minute, guys. Okay. First of all, mole. Let's practice quickly with mole. Mole mean two things. Two things here. Either 1 mole of X. X could be anything. Will give us a number. So mole number here 6.02 times 10 to power 23 of X, of that X thing. Okay, the second meaning, what is a mass? So 1 mole of X will give us either the atomic weight of X, if it's atom, or molecular weight. Of X, if the X molecule. But don't forget this in gram unit. And this represent the molar mass. And also don't forget that these, we will use it as a factor, as a conversion factor, and we can write it down as numerator and denominator when we will do our calculation. Okay, let's practice it quickly with some example for the mole. Okay, if we said, for example, how many mole of let's say, for example, we have how many moles of 16 gram of CO2 we have. Look here, we have 16 gram. Start with that one, 16 gram CO2. Now multiplied by a factor. Guys, which factor you will use? We said mole mean two things, either number or mass. Now, sometimes we need to use one factor, sometimes we need both factor. Look to the information they give it to you. If you have, for example, in the question, mass and mole, we will use the molar mass as a factor, which is 1 mole of X equal either the atomic weight or molecular weight of X in gram unit. If we have mass and mole. If we have number and mole, we will use the Avogadro's number. Avogadro's number, it is 6.02 times 10 to power 23. Don't forget that number. We call it Avogadro's number, and this is the symbol for capital N subscript capital A, which is 1 mole of X, give us 6.02 times 10 to power 23 of that X. Okay, now if you have mass, and number, here we need to use the two factor, both of them. So hopefully this will give you some idea what you're gonna use. So here we have mass, we have mole in the question. So I will use this factor. Now it's very important to know which one will go to the top, how you will write it down, which one numerator, which one denominator. the mass or the mole. We need to cancel. Don't forget this formula. And then times the factor. How you will write down the factor? The wanted or what they are asking will be in the top. The given will be in the bottom. So here I will put the mass in the bottom in the denominator for CO2. What is the mass of CO2? Carbon 12, each oxygen 16 times 2, 32 plus 12 for carbon, so it will give you 44 gram CO2. Okay, and in the top will be the 1 mole. So we can cancel gram CO2 with the gram CO2. Now let's do the math. So what do we have here? We have 16 divided by 44, and it will give us 0.363 or 0.634 mole CO2. Now, let's say, for example, we have this equation. How many molecule of molecule we have in 16 gram CO2? Look at this equation. We have mass and we have number. When we have mass and number, we will use the two factor. Start with the given information. 16 gram CO2 times the first factor. I will use this one first, for example, and it will be 44 gram CO2, 1 mole CO2 here. There's the CO2 here. Gram CO2 with the gram CO2. Now I have the mole, so I will use the second factor. The mole and the Avogadro's number. Which one will go to the top? What they are asking, how many molecules? So they are asking for number. So I will put the Avogadro's number, 6.02 times 10 to power 23 CO2 molecule in the top. And in the bottom, 1 mole CO2. Okay, so more CO2 with more CO2. Do the math right now. So here I will have, let's see, 16 divided by 44 times the 6.02 give me, yeah, just check the number. Always for me, I'm using just my phone to do the calculation quickly. So 2.19 approximately times 10 to power 23 CO2 molecule. Let's practice with one more example quickly. So look here, for example, if they ask for this one, how many gram in 2 times 10 to power 17 water molecule, H2O molecule. Sorry, how many more? Let's say how many more? In 2 times 10 to power 17 H2O molecule. Now look at here, we have mole and we have number. Which factor you will use? I will use the second factor here. Start with the given information, 2 times 10 to power 17 water molecule times a factor. I will use the second factor. Which one will go to the top? Which one will go to the bottom? The number will go to the bottom this time. Okay, 6.02 times 10 to power 23 H2O molecule in the top, 1 more. Now, okay, so there's H2O molecule, H2O molecule. Do the math, and we will have here approximately, let's see, divided by 6. -1, 16. So here it will be approximately 3.3 times 10 to power -7, I think. Just double check. Okay. Yeah, -1, 17 will be 16, and -23. I think -7. Just double check the number. Mole H2O. Okay. This is for the mole. Now let's go and start with the stiocheometry. Let's practice with some example quickly. Don't forget, for the stiocheometry, for mole-to-mole ratio is very important, and we need to balance the chemical equation. If it's not balanced, don't forget that. Sometimes they don't give you a balanced chemical equation, so just be careful. Okay, for stiocheometry, I prefer to use a map to solve the question. What is this map? We have mole X to mole Y. What is X and Y? X and Y, it is any chemical in a chemical reaction. X, it is the given, for example, and the Y, it is the wanted information. So here, mole X to mole Y. How we will go from mole X to mole Y? By using the mole to mole ratio. Mole to mole ratio between X and Y. How I will get the mole to mole ratio? It is the coefficient number of X and Y in a balanced chemical equation. Now, sometimes they give you mass of X. Mass of X. You need to convert it to mole of X. How we will convert it to mole? By using the molar mass, the factor that we already practiced with it on the previous examples. Okay, sometimes they are asking for mass of Y. Mass of Y. How we will go from mole Y to mass of Y? By using the molar mass of Y, here X. Okay, so we have here, when they give you information in the question, the given could be either step 1, which is a mass, or step 2. And what they are asking, they could ask in either for mole of Y, which is a step 3 considered here, or mass of Y, mass of Y, which we will consider it step 4 here. So here, you can use this as a map. To go, for example, from step 1 to step 2, we will use the molar mass of X, of the given information. And if we need to go from step 2 to step 3, we will use the mole-to-mole ratio from the coefficient number of X and Y in the chemical equation. And if we want to go from step 3 to step 4, we will use the molar mass of the Y, which is the wanted unit. Okay, now let's keep this map here and let's practice with this example. Let's say we have this equation. Let's say CH4 plus O2, give me CO2 plus 2H2O, sorry, here 2, yeah, that's correct. Okay, now, first question. How many mole of CO2 produced if we use 3 mole of CH4? Look at here, guys. What they give you, 3 mole CH4. This is the X. What they are asking, mole CO2. This is the Y. What they are asking is the y, what they give you is the x. Now, go back to the map. They give you mole. Where you are, step 1 or step 2. If they give you mole, you are in step 2. They give you mass in gram, you are in step 1. So here they give you mole, so you are in step 2. So start with the 3 mole CH4 here times what? Okay, now look at here. What they are asking for mole of Y. So are you in step 3 or step 4? They are asking for mole, so you are in step 3. They are asking for a mass or gram, you are in step 4. So here we start from 2, we need to go to 3 because they are asking for a mole of CO2. So to go from step 2 to step 3, we need to use the mole to mole ratio, which is this one, between X and Y. Okay, here, which one will go to the bottom? Don't forget it is the X here, which is the CH4. What is the mole to mole ratio between the CH4 and CO2? From the balanced chemical equation, it is 1 to 1. So 1 mole CO2 divided by 1 mole CH4. Okay, so CH4 with the mole CH4, do the math, and we will get here 3 mole CO2. Okay, let's look for another question now. Number 2, for example. How many grams of CO2 produced if we use 16 gram O2? We will do the same things. They give you 16 gram, which is the given information, which is the X. Where are you, step 1 or step 2? Gram, so I'm step 1. What they are asking for gram. So Y, it's the CO2 here. So it will be step 4. So I will go from step 1 to step 4. How you will go from step 1 to step 4? You will go step by step. First of all, start with the given information. 16 gram O2 times what? To go from 1 to 2, from step 1 to step 2, I need to use the molar mass of X, which is the O2. How you will use it? Which one will go to the top? Which one will go to the bottom? Here, the mass will go, gram will go to the bottom. What is the molar mass of O2? 2 oxygen times 16 will be 32. So it will be 32 gram O2 here, and 1 mole in the top. Now, I'm in step 2. I need to go to step 3 by using the mole to mole ratio between X and Y, between O2 and CO2 in the balance chemical equation. What is the coefficient number? What is the mole to mole ratio? Which one will go to the top? Which one will go to the bottom? In the bottom, I will put the 2 mole O2 because I have coefficient number 2 in the balance chemical equation. And in the top, I will put 1 because I have 1 mole CO2. And so mole O2 with mole O2, gram O2 with the gram O2. Now we are in step 3. We need to go to step 4 by using the molar mass of Y, which is the CO2 here. How you will write it down, which one will go to the bottom, which one will go to the top, the gram or the mole. They are asking for the gram, so it will be the molar mass, the mass CO2 here, 44. So 44, 12 for the oxygen, 2 times 16 for the oxygen, add them together, give you 44 gram CO2. And here in the bottom, 1 mole CO2. Cancel this one, do the math right now. So here, 16 divided by 32 give you 0.5, divided by 0.25, I think it will equal 11 gram CO2. Just double check the math, guys, okay? And that's what we're gonna do. Guys, I encourage you to use this map. This map will help you always for starting with online homework, with the quiz, in the exam. So always put it in front of you and keep working on it, and you can solve any question. And be careful, guys, how you will go from step 1 to 2 or to 3 to 4, which factor you will use, which one will go to the top, which one will go to the bottom. Be careful with this situation. Okay, so let's start with the practicing with the limiting reacting and percent yield right now. Okay, so we will practice with some example here. Okay, so okay, let's practice with this one. Okay, you are giving 74 gram of nitrogen gas. How much hydrogen gas do you need? And two, nitrogen gas, hydrogen gas. Okay, now be careful, guys. Just one thing before start with this one. Always nitrogen gas, hydrogen gas, all these will be N2, H2, oxygen gas, O2, cloning gas, Cl2, diatomic molecule element. We have seven, F2, I2, Br2, always is diatomic molecule, especially when you are trying to calculate the molar mass of each of them. So it is two, so be careful. Or sometimes they name it oxygen molecule, nitrogen molecule, hydrogen molecule. So it will be also an N2, O2. Only when they told you oxygen atom, nitrogen atom will be single nitrogen or single oxygen or a single hydrogen. When they said oxygen atom or nitrogen atom. But if they said oxygen molecule, nitrogen molecule, or oxygen gas, nitrogen gas, hydrogen gas, all these diatomic molecules. So be careful of it. Okay, you're given 74 gram of nitrogen gas. How much hydrogen gas do you need? Let's start with the given information. 74 gram N2 times what? We are in step one in the map, and they are asking for a gram of nitrogen. So how much hydrogen gas do you need? Actually, here is a little bit confusing because they didn't ask how many gram or more, but let's assume there is a gram. Okay, we need to go from step one in the map to step four. First of all, to go from step one to step two, we will use the molar mass of nitrogen, of X. Which one will go to the bottom? It is the gram. So here, nitrogen to nitrogen, so it will be 28 gram N2. Guys, I will just do the mathematical calculation, but I will not give you the final answer. You can do it in your calculator and find the final answer, just to give you quickly more example. Okay, 28 gram of nitrogen in the bottom, 1 mole and 2 in the top. Now, times what? Now we need to go from step 2 to step 3. The mole to mole ratio between N2 and hydrogen. Now also, which one will go to the bottom? It is the nitrogen. It is the X. So here 1 mole N2, and in the top there will be 3 mole H2. This is the 3, this is the 1. Okay, now we are in step 3. We need to go step 4. I will use the molar mass of Y, which is the H2 hydrogen gas. So which one will go to the top? It is the mass this time. What it is the 2 hydrogen, so it will be 2 times 1, so it will be 2 gram H2 and 1 mole H2 in the bottom. Cancel mole 2 with mole H2. Do the math here, and you will get here a gram H2. Yes. As I said, try to get the number, do the calculation by yourself, by your calculator, and you will get the numbers. I just want to go and give you as much as I can example. Okay, let's go to this question. What is the theoretical yield of aluminum oxide by starting with 50 gram of aluminum metal? Guys, the theoretical yield, it is the calculated yield. Calculated yield. You remember, I don't know if you saw these in the PowerPoint slides, they are talking about theoretical yield and actual yield. Actual yield is the real yield that we get it after doing the experiment. Theoretical yield, it is the calculated one, okay? Theoretical, the calculated one. And these, we will need it if we need to calculate the percentage yield. So calculated yield. Now, just be careful. Always the theoretical yield, it is the calculated yield that's coming from the limiting reacting. It is the one that's coming from the limiting reacting. Okay. What is the theoretical yield? Let's start with the 50 gram. So look at here. They're asking for Al2O3. What is the theoretical yield? Let's assume it's in a gram. So we need to go from step 1 to step 4. Step 1, it is 50 gram aluminum metal. It is this one. Times the molar mass. 1 mole Al divided by the molar mass. It is 27 approximately a gram aluminum. So gram aluminum. Then we need to go from step 2 to step 3 by using the multimole ratio between Al2O3, aluminum oxide, and the aluminum. Which one go to the bottom? It is the 4 mole aluminum. In the top, 2 mole Al2O3. Now we are in step 3, so we will need to go to step 4 by using the molar mass of Al2O3. The mole will go to the bottom, 1 mole Al2O3, and in the top, we will calculate the molar mass. So here, the gram, 2 times 27 for the aluminum, plus 3 times 16 for the oxygen. Here we will get 54 plus 48. So it will be 102. Guys, double check always the number. So after me, if I'm not using the calculator. So here 102 gram Al2O3. Cancel mole aluminum with a mole aluminum. Mole Al2O3 with mole 3. Now do the math. 50 times 2 times 108 divided by 27 times 4 and times 1. What we're going to do here, what we're going to get here, it is the gram Al2O3 here, which is the theoretical yield of aluminum oxide. Okay, now let's go here. What mass of iron 3 oxide Fe2 is required to produce 10 gram of iron? Okay, I will leave this because we already practiced with 2 examples similar to this. So try to do it as homework. Do it by yourself, okay? Okay. Let's look for this one. Given 100 gram each of Si2 silicon and carbon. How much carbon could you make? Okay. Okay, so here we have 100 gram of Si2 and 100 gram of carbon. So here we will start with 100 gram Si2 and 100 gram carbon. Now we need to know how much carbon random SiC. Okay, the silicon carbide. So how much we will make the SiC? In this situation, we need to calculate how much SiC will form from both reacting. And then we will decide how much would you make. because here the maximum amount depending on the limiting reactant here. So let's start, for example, with 100 gram Si2. Now times the molar mass of Si2. So here will be 1 mole Si2 divided by the molar mass Si2, Si20, let's say 28 plus 2 oxygen 32 will be here 60 gram approximately SiO2. So the gram SiO2 with this one. Now times the mole to mole ratio between SiC and the SiO2, which is 1 to 1. 1 mole SiC, 1 mole SiO2. Okay, so mole SiO2 with this one. Now times the molar mass here, 1 mole SiC. And in the top, what do we have? The mass for the SiC plus 20 approximately, 28 plus the 12 for the carbon, approximately 40 or 40 point something. Okay, 40 gram SiC. Now we did the math and let's see what we're gonna get, of course, here. So we will have here 100 times 40 divided by 60, we will get 66.7 approximately a gram. Now let's calculate the SiC from carbon. Do the same things, but this time 1 mole C divided by 12 gram C times. What is the mole to mole ratio between SiC and carbon? 1 to 3. 1 mole SiC, 3 mole carbon times the molar mass of SiC, 40 gram SiC, and 1 mole SiC. Okay, so mole C, this one, mole C with mole C, gram C with gram C. Do the math. And now we have 100 times 1 times 40 divided by 12 will give us 333.3 approximately gram SiC. Now look at here. The SiO2, the 100 gram Si2 gives you 66.7 gram SiC. The 100 gram of carbon gives you 333.3 gram SiC. How much it will form? How much? What do you think, guys? Here, we will go with the limiting reactant. Which one is the limiting reactant? It is the one that will give you the lowest yield. Which one is the lowest amount yield? It is this one. Now, this represent our theoretical yield. Theoretical yield, not this one, guys, not this one. Because this theoretical yield, which is the lowest yield could form, it's coming from the limiting reactant, Si2. So here, Si2 is the limiting reactant. And that limiting reactant, it gives us the theoretical yield. Don't forget that. Okay, let's go on to practice with more example. Let's look at this one. We have this reaction. MnO2 plus 4Al give us 3 Mn liquid, and we have 2 plus 2Al2O3. Given 50 gram of MnO2 and 20 gram of aluminum, a total of 16 gram of Mn was isolated. So look at here, when you have these questions, here they are asking, for example, for theoretical yield first. We try to find then the limiting reactant, the percent here. Look at here, when you have something like that, a total 16 gram of Mn, for example, of any chemical was isolated. This represents your actual because we will need it for the percentage. Now we're missing the theoretical. How you will find the theoretical, and they are asking for the theoretical again, and also the limiting reactant. So here we have these two amount of reactant, 50 gram MnO2 and 25 gram aluminum. So we will calculate how much manganese it will produce from each of them. Now, sometimes if they didn't mention which product, it's your choice to choose one product for both of them. Don't choose, for example, manganese for aluminum, Al2O3 for MnO2. No, I will choose one product and do it for both of them. But here they specified manganese, so I will keep it for manganese. Okay, now let's look here. What do we have? How we will start? So we will start. Okay, let's add a new slide here. Okay, so look here, we have 50 gram MnO2. So I'm going to start with 50 gram MnO2 times the molar mass of MnO2, what it is. 1 mole MnO2 divided by manganese. Okay, so here we have 55 for manganese plus 32. And we will get here 87 gram. Okay, 87 gram MnO2 is the molar mass, or is the molar mass of MnO2. Now, times the mole-to-mole ratio. Let's go back to the reaction. 3 MnO2, 3 Mn, so 3 to 3. So here 3 mole MnO2, 3 mole Mn. Now, times the molar mass of manganese, what it is? It is 55. So here, which one will go to the bottom? It will be the mole. 1 mole Mn in the top, 55 gram Mn. Okay, so mole Mn, this one, mole MnO2 with mole MnO2, gram MnO2 with this one. Okay, let's do the math right now. So we have 50 times 3 times the 55, now divided by 87, divided by 3, we will get here 31.6 gram manganese. Okay, this is from MnO2. Now 25 gram aluminum. We will do the same things and we will calculate how much aluminum from 25 gram aluminum, isn't it? 25, yeah. Okay, times the molar mass. 1 mole Al divided by 27 gram aluminum times the molar mass, the mole-to-mole ratio between aluminum and manganese. 4 aluminum and sorry, not this one. 4 aluminum and 3 mole manganese. So here 4 mole aluminum, 3 mole manganese times the molar mass of manganese, which is 55 gram manganese divided by 1 mole manganese. Okay, so mole Mn, mole aluminum with mole aluminum, gram aluminum with gram aluminum. Let's do the math right now. So we have 25 times 3 times 55 for this, divided by 27 divided by 4. We will get here 38.2 gram manganese. Now look at here. What they asked. Which one is the theoretical yield? Which one is the limiting reactant? And they are asking for percent yield. Now, first of all, Which one is the limiting reactant? It is the reacting, supposed to be reacting, now product. Be careful, guys. It is the reactant that give you the lowest yield. Which one is the lowest yield? It is this one. Now, that reacting here that give you the lowest yield, it is the limiting reactant. Limiting reactant. So it is the MnO2. Now, which one is the theoretical yield? It is the yield that's coming from the limiting reactant. So it will be this one, theoretical yield. Okay, now they are asking for the actual, percentage yield in C. They give you actual yield, 16.6 grams, and we calculated the theoretical yield here. So how you will calculate the percentage yield? So here, the percentage yield, like the actual divided by theoretical times 100. The actual 16, let's say, sorry, 16.6. 16.6 gram divided by theoretical, it is 31.6 gram times 100. So let's see what we will get here is the percentage. So 16.6 divided by 31.6, we will get here 52.5% yield. And that's represent percentage yield for our reaction. So be careful, guys, how you will calculate or how you will deal with this type of question. First of all, we need to find the limiting reactant. It is the one that will give you the lowest yield. And that yield coming from the limiting reactant will be the theoretical yield. And usually they give you the amount of a gram or amount of any chemical was gained or isolated in the reaction, which represent the actual yield. And you will use this formula to calculate the percent yield. That's how you will deal with these type of a question. So as I say, guys, be careful. We are dealing here with a lot of numbers, calculation, but be careful always. Go and working step by step and always check your number, check which one will go to the top, which one will go to the bottom. This is very important. Okay.